Electric space heaters use a lot of electricity, which can stress electrical circuits and cause overloads. Even if they're not used all the time, the total amount of power they draw can still be a problem. One option is to install 4 20-amp circuits. Firstly, 2 circuits for the bedrooms, each with arc fault circuit interrupter or AFCI protection. Secondly, 1 circuit for the common area, also with AFCI protection. Thirdly, 1 circuit for the bathroom without AFCI protection. This setup gives dedicated circuits for things that use a lot of power, like space heaters, and keeps the lights working even if a heater breaker trips. Another option is to install 3 20-amp circuits with AFCI protection for the bedrooms and common area, and install 1 15-amp circuit for the bathroom and lights. This way uses fewer AFCI breakers, but it might limit how many things you can plug into the light and bathroom circuit. It's important to clearly explain the risks of using electric space heaters as the only way to heat the space. Talk about how important it is to have a safe electrical system and avoid overloads. If they still want to use space heaters, tell them to be very careful and think about adding more smoke alarms. Also, check the existing panel to make sure it's in good shape and can handle the extra circuits. You might want to put in an AFCI outlet adapter for the bathroom circuit to give extra protection to the exhaust fan and receptacle. Suggest putting in a ceiling fan in the common area to help circulate air and reduce the need for space heaters. Keep a written record of all your conversations and advise to protect yourself from any legal problems. Make sure to follow all electrical codes and standards to keep the installation safe. If you choose to install 4 20-amp circuits, 2 for the bedrooms each with AFCI protection, 1 for the common area with AFCI protection, and 1 for the bathroom without AFCI protection, you achieve dedicated circuits for high-load devices like space heaters. This allows the lights to remain operational even if a heater breaker trips, enhancing safety and convenience. The use of AFCI protection in bedrooms and common areas is crucial for preventing electrical fires caused by arc faults, which are common in older or damaged wiring. A bathroom circuit without AFCI protection is permissible under certain codes, but it is wise to consider an AFCI outlet adapter for added safety, especially near water sources. The alternative of installing 3 20-amp circuits with AFCI protection for the bedrooms and common area plus 1 15-amp circuit for the bathroom and lights represents a balance between cost and safety. While this setup reduces the number of AFCI breakers needed, it might limit the number of devices that can be used on the light and bathroom circuit. Careful consideration should be given to the expected load in the 15-amp circuit to avoid overloading, especially if multiple lights and appliances are used simultaneously. Effective communication with the homeowner is paramount. Clearly explain the potential risks and consequences of relying solely on electric space heaters for heating, emphasizing the strain on electrical circuits and the possibility of overloads. Discuss the importance of maintaining a safe electrical system and avoiding the use of multiple high-wattage devices on a single circuit. If the homeowner insists on using space heaters, stress the need for extreme caution and suggest the installation of additional smoke alarms as a safety measure. Inspecting the existing panel is a critical step to ensure it is in good condition and capable of accommodating the additional circuits. Look for signs of damage, corrosion, or overheating, and verify that the panel has sufficient capacity to handle the increased load. If the panel is old or undersized, consider recommending a panel upgrade to ensure the electrical system's safety and reliability. Installing an AFCI outlet adapter for the bathroom circuit provides an additional layer of protection for the exhaust fan and receptacle. AFCI outlet adapters are designed to detect arc faults and quickly shut off the power, reducing the risk of electrical fires. This is particularly important in bathrooms where moisture and humidity can increase the likelihood of arc faults. Recommending the installation of a ceiling fan in the common area can improve air circulation and reduce the reliance on space heaters. Ceiling fans help distribute warm air more evenly throughout the room, making the space more comfortable and energy efficient. This can decrease the amount of time space heaters are needed, reducing the strain on electrical circuits. Documenting all conversations and recommendations with the homeowner in writing is essential for protecting yourself from potential liability issues. Maintain a detailed record of the advice you provided, the warnings you issued, and the homeowner's decisions regarding the electrical system. This documentation can serve as evidence that you acted responsibly and informed the homeowner of the potential risks involved. Adhering to all applicable electrical codes and standards is crucial for ensuring the safety of the installation. Consult the National Electrical Code, or NEC, and any local codes that may apply to the project. Follow all guidelines for wiring, circuit protection, grounding, and bonding to minimize the risk of electrical hazards. Failure to comply with electrical codes could result in fines, penalties, and legal liability. In Minnesota, where winters are severe, the continuous operation of electric space heaters can place a significant strain on the electrical system. Electric space heaters typically draw a large amount of current, often close to the maximum capacity of a standard 15 amp or 20 amp circuit. If multiple space heaters are used simultaneously on the same circuit, it can easily lead to overloading, causing the breaker to trip and potentially creating a fire hazard. Consider the load calculation for each circuit. A standard 15 amp circuit at 120 volts has a maximum capacity of 1800 volt amps, while a 20 amp circuit at 120 volts has a maximum capacity of 2400 volt amps. The electric space heaters can draw anywhere from 750 volt amps to 1500 volt amps or more, depending on the model and heat setting. Before adding any new circuits, it's important to assess the existing load on the electrical panel to ensure that it can handle the additional demand. Calculate the total load of all existing circuits, including lighting, appliances, and other electrical devices. Compare this total load to the panel's capacity to determine if there is sufficient capacity to add the new circuits. If the panel is already close to its maximum capacity, it may be necessary to upgrade the panel to a larger size. The use of arc fault circuit interrupters, or AFCIs, is crucial for protecting against electrical fires caused by arc faults. Arc faults occur when there is an unintended electrical discharge between two conductors, often due to damaged or deteriorated wiring. AFCIs are designed to detect these arc faults and quickly shut off the power, preventing the arc fault from escalating into a fire. The NEC requires AFCI protection in many areas of the home, including bedrooms, living rooms, and other living areas. Ground fault circuit interrupters, or GFCIs, are essential for protecting against electrical shock in areas where there is a high risk of moisture, such as bathrooms and kitchens. GFCIs are designed to detect ground faults, which occur when electricity flows through an unintended path to ground, such as through a person's body. GFCIs quickly shut off the power when a ground fault is detected, preventing electrical shock. The NEC requires GFCI protection for all receptacles in bathrooms, kitchens, and other areas where there is a high risk of moisture. The use of tandem breakers, also known as half-size breakers within breakers, can allow you to install more circuits in a panel that is already full. Tandem breakers are designed to fit two circuits into the space of a single standard breaker. However, it's important to ensure that the panel is rated to accept tandem breakers, as not all panels are designed for this purpose. The panel's labeling will indicate whether it is compatible with tandem breakers. When installing new circuits, it's essential to use the correct wire size for the intended load. The NEC specifies the minimum wire size for different ampacities. For example, a 15 amp circuit typically requires 14 American wire gauge, or HOG, copper wire, while a 20 amp circuit typically requires 12 AWG copper wire. Using the correct wire size ensures that the wire can safely carry the intended current without overheating. The proper grounding and bonding of electrical equipment is critical for preventing electrical shock and ensuring the safety of the electrical system. Grounding provides a path for fault current to flow back to the source, allowing the breaker to trip and to energize the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. The NEC specifies the requirements for grounding and bonding electrical equipment. When installing receptacles, it's important to choose the correct type for the intended use. Standard 15 amp receptacles are suitable for general purpose use, while 20 amp receptacles are required for circuits that supply heavy loads, such as appliances. Tamper-resistant receptacles, or TRRs, are required in areas where children are present, as they prevent children from inserting objects into the receptacle slots. Weather-resistant receptacles are required for outdoor use, as they are designed to withstand exposure to the elements. The installation of smoke alarms and carbon monoxide detectors is essential for protecting the occupants of the home from fire and carbon monoxide poisoning. Smoke alarms should be installed in every bedroom as well as in hallways and common areas. Carbon monoxide detectors should be installed near sleeping areas. Ensure that the smoke alarms and carbon monoxide detectors are properly installed and maintained, and that they are tested regularly. If the homeowner is planning to install insulation in the attic, it's important to ensure that the insulation does not cover or obstruct any electrical boxes or wiring. Electrical boxes and wiring need to be accessible for inspection and maintenance. Covering electrical boxes or wiring with insulation can create a fire hazard by trapping heat and preventing proper ventilation. The use of LED lighting can significantly reduce the energy consumption of the lighting system. LED lights are much more energy efficient than traditional incandescent or fluorescent lights, using up to 75% less energy. LED lights also have a much longer lifespan, reducing the need for frequent replacements. Consider recommending the installation of LED lighting throughout the attic space to reduce energy costs and improve energy efficiency. The proper ventilation of the attic space is essential for preventing moisture buildup and maintaining a comfortable indoor environment. Insufficient ventilation can lead to condensation, mold growth, and damage to the building structure. Ensure that the attic space has adequate ventilation, such as soffit vents, ridge vents, or gable vents. The size and number of vents should be determined based on the size of the attic space and the local climate conditions. When running new wiring, it's important to protect the wiring from physical damage. Wiring should be run through conduit or other protective materials in areas where it is exposed to physical damage, such as in unfinished basements or attics. Wiring should also be properly supported and secured to prevent it from sagging or rubbing against other objects. The use of surge protection can protect sensitive electronic equipment from damage caused by power surges. Power surges can occur due to lightning strikes, utility switching, or other electrical disturbances. Surge protectors divert excess voltage away from the equipment, preventing damage. Consider recommending the installation of surge protection for the entire electrical system, as well as for individual electronic devices. The electrical system should be inspected regularly to ensure that it is in good condition and operating safely. The NEC recommends that electrical systems be inspected at least every 3 years. Inspection should be performed by a qualified electrician who can identify potential hazards and recommend necessary repairs or upgrades. If any electrical work is performed in the attic space, it's important to obtain the necessary permits from the local building department. Permits ensure that the work is performed in accordance with electrical codes and standards, and that the installation is safe and compliant. Failure to obtain permits can result in fines, penalties, and legal liability.